Hey everybody, Mr. Judson here. So we're backtracking to section 6 out of chapter 2, and our goal in this section is to be able to graph rational functions, which means fractions. Not like what we saw in chapter 1, we had our special rational function. Now we're saying any fraction, okay? And so to be able to graph these, there's a couple things we want to be able to do. One is we got to figure out where asymptotes are. The second thing is we want to be able to find zeros. Those are going to be our key items to help us draw a graph in the right spot. So that's really what our focus is going to be for today, is to find those items. And then what we'll do is, for the next video, we'll work more on the graphing part. Okay? So we want to be able to find zeros, which we've already practiced this. To find zeros, the only way a fraction can equal 0 is if the numerator equals 0, right? Our second thing is we want to find vertical asymptotes. Okay, so these are the asymptotes that run up and down. And then we also want to find horizontal asymptotes. Okay, so those are our three main goals for today. So first of all, we know how to find zeros. This is when the numerator equals 0. Okay? Remember, you do not want denominators to equal 0. I'm never going to change that rule. Okay? Wherever the numerator equals 0, those are our zeros for the function. And remember, zeros are x-intercepts, where you cross the x-axis. Okay? Vertical asymptotes, that's when the denominator equals 0. Okay? So, when the denominator is equal to 0. Sort of. We got to be careful. If both numerator and denominator equals 0, meaning if I've got the same factor in the numerator and denominator, then it's not a vertical asymptote. Something else happens. We'll get to that. I guess that's our fourth item that we'll talk about, is a hole in the graph. Okay. Horizontal asymptotes, we're going to have to lay out some rules for this. But that's just an asymptote that's horizontal, and our graph will get really close to without touching. Okay? All right, so let's develop some rules for the horizontal asymptotes. If I have a function that is f of x equals ax to the n power plus, and then I've got some more terms. So what we're going to do is we're going to say this is our highest exponent. All right? Over b x to the m power plus some more stuff. Okay? So I've got an expression in the numerator, I've got an expression in the denominator, and what I want to do is I want to look at those two exponents. All right? And so if n is less than m, anytime this exponent is smaller than this one, then there's a horizontal asymptote. I'm just going to abbreviate that HA. A horizontal asymptote at y equals 0. So y equals 0 just means I've got a horizontal line that goes through the y-axis at 0, which is the x-axis, right? So anytime the exponent in the numerator is smaller than the denominator, then there's an asymptote on the x-axis. That's what we're saying right here. Okay? You can erase that and write x-axis if you want. Okay? If n is equal to m, so if this exponent is equal to this exponent. Now again, we're looking at the two highest ones. The highest one in the numerator, highest one in the denominator. If they're equal to each other, then there's a horizontal asymptote at y equals, we look at these leading coefficients, and whatever a divided by b is, that's where the asymptote is. A divided by b. So if this is 6 and this is 2, 6 divided by 2 is 3, the line y equals 3 is a horizontal asymptote. We would just draw that in our graph and know that our graph gets close to it without quite touching. Okay? All right, so there is one more type of asymptote that happens sometimes. If n is larger than m by 1, okay, if it's 1 larger, what I would have to do is I'd have to go through and do long division, and my answer would look like a linear equation plus some remainder. And what happens is that linear equation becomes a slanted asymptote. We're not going to do that, again, because I need to find some things to cut out. This doesn't happen that often. It doesn't happen on the Central Washington final. And so we'll just let it go. But just know that it's a possibility. Sometimes you get a graph that has a vertical asymptote and a slant asymptote, and your curves look like this. Okay? That happens sometimes. But we're not going to do those. We're going to stick to just vertical and horizontal asymptotes. All right? So let's do a practice problem where we can find all this information. All right, so here's a rational function. It's a fraction, right? It's a messy one. And what we want to do is we're not going to graph these today. We're just going to find pieces that are important. All right? We want to find the zeros, and we want to find the vertical asymptotes, and I want to find the horizontal asymptote. There will only be one horizontal asymptote. There can never be two. Okay? Well, I shouldn't say never. I think there are some equations that can make that happen, but they're pretty rare. Okay? Very rare. It is common to have more than one vertical asymptote. We haven't seen that yet, but you could have an asymptote here and another one over here. Okay? That stuff happens. So what we want to do is we want to find the zeros and all vertical and horizontal asymptotes. Okay? And so what I want to do first, before I do anything, is you guys' favorite thing to do, factor, right? I got to factor this. So I'm going to say that this is equal to, if I factor an x out, I'm left with x minus 1. In the denominator, if I factor this, I would have, this would be x times x. Two numbers you multiply to get 15 and subtract to get 2. Sounds like 5 and 3. I want a positive 2, so I'm going to say positive 5, negative 3. And it doesn't matter if you have the positive 5 over here and the negative 3 here. That doesn't matter. Okay? So I would look at this now and I would say, okay, the zeros are going to be at x equals 0 and 1. We got to keep on saying this in our head. The only way a fraction can equal 0 is if the numerator is 0. I mean, think about it. Here's a fraction, okay? I've got something over 4. What number are you going to put here to make this equal 0? There's only one number. Okay? Here's another fraction. Let's say I've got 5. What number are you going to put here to make this equal 0? Tell me you didn't say 0. Denominators never get to equal 0. Never. You can't make this fraction equal 0 because the numerator doesn't equal 0. Right? Alright, so the only way a fraction can equal 0 is if the numerator is equal to 0. So my zeros are going to be at x equals 0 and 1. If I plug a 0 in here, I've got 0 times a negative 1, which is 0, and the numerator equals 0. If I plug a 1 in here, I've got 1 times 0, and that equals 0. Okay? That's it. Vertical asymptotes only happen when the denominator equals 0. We just said that right here. Vertical asymptotes happen when the denominator equals 0. Right? So that would happen at -5 and +3. So this would be at x equals -5 and +3. So remember, on a graph, here's a quick graph. When I say that there's a vertical asymptote at x equals -5, what I'm doing, there we go. If I put a dotted line right here and a dotted line at 3, what we're saying is your graph can't touch that line. You can't touch it, because if you do, your denominator will equal 0, and this is undefined. So essentially the dotted line here means we're undefined at all of these points at 3 comma whatever, or -5 comma whatever. You can't touch those lines. Okay? That's what we're saying. We say there's a vertical asymptote. Those x coordinates are off limits. All right? Okay, the last thing I need is a horizontal asymptote. So when I go back and look at this, my exponents are equal to each other. So I want to ask myself, what are the two numbers out in front? And when you don't write anything, they're 1s. So 1 over 1 means there's going to be a horizontal asymptote at y equals 1. 1 divided by 1. Okay? All we're trying to do is find this information for today. Tomorrow we're going to use it. Okay, or in our next video. And again, just to make sure that this makes sense to everybody, just so we get this, if I bring a coordinate system out here, this is what I know. I know that there's vertical asymptotes at x equals -5, so there's a dotted line I can't touch. There's a dotted line I can't touch. There's a horizontal asymptote at y equals 1. Now, I know this sounds kind of weird, but it happens. You can touch a horizontal asymptote. It does happen sometimes. But as you go way out here to infinity, that's where you get close to this dotted line without touching. And same thing if you go way out this direction. This should extend out here farther, and this should go out farther. As you go way out here, you get really close without touching. Okay? And my zeros are at 0 and 1. I'm not allowed to cross the x-axis anywhere else, because those are my only zeros. It's the only place you can touch the x-axis. I feel like I know what the graph looks like already. Both of those had a multiplicity of 1, so I have to go through the x-axis, get close to these asymptotes without touching. There's got to be something out here, and I know it's up here because if it was down here I would hit the x-axis again, right? There aren't any more zeros. I can't hit the x-axis here, so my graph has to be up here. I kind of think that's what this graph looks like. Now, am I perfect? I don't know. I think I'm close. Okay, but we're not getting to this today. All we want to do is find this information, but we're going to use it to start producing graphs. Okay? All right, let me get rid of that. I just wanted you guys to see where we're going with this. All right, so this one's a little bit easier. We want to find the zeros, the vertical asymptotes, and the horizontal asymptotes. You guys go ahead and try it. All right, so for my zeros, the only way a fraction can equal 0 is if the numerator equals 0. Move that 1 over, you get 2x equals 1, divide by 2, x equals 1/2. There's my 0. Okay, now you guys should be able to just look at this and go opposite of that divided by this, just like as if it was a factor. Okay, there's going to be a vertical asymptote at x equals -2, whatever makes the denominator equal 0. And when I look at these, the exponents are the same. So if I do 2 over 1, that's just 2. There's a horizontal asymptote at y equals 2. That's the information we need for today. Let me have you guys try one that's a little more difficult than this on your own. All right, so here's one that's a little more complicated. So same thing, we want to try and find all the zeros and all the vertical asymptotes and horizontal asymptotes. You guys go ahead and try. All right, so first thing I need to do is I need to factor both numerator and denominator. Denominator is not too bad. That's x plus 3 times x minus 3. Difference of 2 squares. This would be x times x. Over here I need two numbers. I'd multiply to get 8 and subtract to get a -2. So that sounds like 2 and a -4. So double check it. X squared, -4x plus 2x, that's -2x. And then I get a -8. Okay? So my zeros are at x equals -2 and +4. My vertical asymptotes are at x equals, so these are actually x numbers right here. When I say x equals -3 and x equals +3, now I'm talking about lines because asymptotes are lines. We draw them as dotted lines, but they're going to go through the x-axis at -3 and through the x-axis at 3. Zeros are just numbers that make your equation equal 0. Or they're like x-intercepts, -2, 0 and 4, 0. Okay? And then my horizontal asymptote, again when I look at that the exponents are equal. So 1 divided by 1, that's y equals 1. Okay, so today we're just gathering information. Gathering information that we can apply and then produce a graph out of it, and we'll do that tomorrow. So let me have you guys just try one last problem. All right, this one looks a little scary, but you know, again, it's no different, the procedure, than the previous one. We're just going to do the same things. Find the zeros, find your vertical asymptotes, find the horizontal asymptote. All right, so numerator, I can factor that. X plus 2, x minus 2. Denominator, I'm going to have to use some synthetic division to factor that. So off to the side here, I'll just say 1, 4, 1, -6. And I'm going to do some synthetic division with numbers that divide into 6 evenly. I do see that these add up to 0. Right? 1 plus 4 plus 1 is 6, -6, that's 0. That means 1 works. Oh, I drew this the wrong way. Let me fix that. Alright, so I'll bring the first number down, I'll multiply and add, so that'd be 1 plus 4, that's 5. Then 5 plus 1, that's 6. 6 minus 6, that's 0. So there's one of my factors, x minus 1. I got some more in there, so let's see, x squared plus 5x plus 6. If I factor that, I get x times x. Two numbers you multiply to get 6 and add to get 5. Got to be 3 and 2. So x plus 3, x plus 2. So there's something that happens here that's a little bit different. I've got that factor and that factor are the same, so they cancel, but what that means is there is a hole in the graph at x equals -2. You know, again, whatever makes this equal 0. There's a hole in the graph. We're still undefined because if you plug in a -2, you're going to get 0 in this denominator. So that just means there's a hole in the graph. What does a hole look like? It's when your graph goes like this and then there's a hole and then it continues on. It's like there's a break in the graph. Okay? We'll graph some of these later on the calculator and we'll see that hole show up. But that's what that means. And so, you know, now, instead of having all those factors, what I really have is this. X minus 2 over x minus 1 times x plus 3. Okay, but I just want to remember there's a hole in the graph at that x value. So now I could say that my zeros happen whenever the numerator equals 0. So at x equals 2. I've got vertical asymptotes at x equals 1 and x equals -3. Remember, these are lines. This is just a point on the x-axis. And when I go back and look at the original function, this exponent up here is less than the one in the denominator. That means the horizontal asymptote is on the x-axis. It's the line y equals 0. So horizontal asymptote at y equals 0. Okay, we're not going to worry too much about this yet. We'll see what that means when we start graphing the functions. All right, that's it. That's all we have for today. Not a huge amount of work, but a really important piece of work to help us understand how to graph things tomorrow. All right, let me get you guys an assignment. All right, there it is. So number 13, this is our Wednesday piece. We're on page 193. We're going to do 5 to 25 odd. I just want to make one last comment. Some of the questions say to describe the domain of this function. Well, the domain is that x cannot equal 1 or -3 or -2. That's all you got to say. It's the same thing where our vertical asymptotes are. X cannot equal those numbers. That's why we're putting that dotted line there. At x equals 1, there's a dotted line, and we're saying we can't equal that. Okay, you can't cross that dotted line. You could also give your domain in interval notation. You know, if you say x cannot equal 1 or -3 or -2, then we've got from -infinity to -3, that interval. Then the interval from -3 to -2. Then from -2 to 1, and then from 1 to infinity. I think it's easier just to say x cannot equal 1, -3, or -2. You have to include this, even though we canceled it, x still cannot equal a -2. That's why we're going to have a hole in the graph later. If I look at this one, my domain is x does not equal -3 or +3. That's it. All right? So, that's what we have for today. All right, you guys stay safe, take care. We'll see you on Thursday or Friday. Bye.